Right. Yes. Yes, it says I'm live. Hey, welcome everybody. Come on in. I usually take a few minutes at the beginning of this live stream to just sort of sit back and relax and let everybody come on in. Welcome to Astronomy Discourse Live. So this used to be Astronomy Daily Live, but since I'm having to do this at my day job now, I'm not going to be here all the time. So it's not going to be a daily thing. It's just going to be when I'm here. So 3 or 4 or 5 days a week or so, usually the weekdays. Um, but yeah, so I hope everybody's doing well. Come on in. Saw Uncle Bill in the chat earlier, but I think he's just lurking around. So yeah, come on in. This is a discourse on all things astronomy, space, science, nerdy things, all that kind of stuff. And it's, completely casual, no script, no plan, no editing, nothing at all. One of my favorite words in the whole world, and it's a 4-letter word. I've got a lot of favorite 4-letter words, but one of my favorite 4-letter words is easy. EASY. Hey there, Andy. How you doing? Hope everything's well over there. I think Andy's over in the UK, if I remember right. So yeah. Hopefully, this time, I changed my location. I changed the name of the live stream, and I also changed the time. So now it's happening at 22 hours UTC. So over in the UK, I guess it depends on daylight savings time over there too. It's not quite as late over there. I think in the UK right now, isn't it? Is it 11 p.m. there, or is it 10 p.m.? I guess it's probably maybe 11. Oh, I don't know. Maybe it's 9. I don't know. But the cool thing is, for me, and this goes again with the easy part, right? Is that it just so happens that I am in the state of Arizona in the United States. I'm in the southeastern part, so I'm way down there. I'm just I think line of sight. I'm probably maybe 20 to 30 miles north of the Mexican border, and actually about the same to New Mexico. So I'm just way down in the corner. Okay, so it's 11 p.m. in the UK at the moment. Anyway, Arizona, the state of Arizona, is one of the few states, a couple of states, in fact, a couple of locations in the world where daylight savings time is not recognized at all. So I am always 7 hours behind UTC. So it's 22:03 UTC right now, and it's 3:03 p.m. here. So, and that will never change, and that is easy. Yeah, Patrick, I looked at Zoom, and I think that is a nice option. But yeah, one of my other favorite words. It isn't a 4-letter word, but it's a 5-letter word, and that is cheap. I am cheap, and not because I think in a cheap way, but it's just I am rich. I am wealthy. I am wealthy in practically every way, except when it comes to dollars. And part of that, actually most of that, is a choice on purpose. I just don't find a lot of use for those kinds of things, so I don't really want or need a lot of them. And so, you know, when something wants those dollars, I just don't have them, um, it's not necessarily a bad thing, but I think what I'm going to do is and I probably need to experiment with this a little bit before we actually do it. Oh, by the way, I've got some background music playing. I hope you can hear it. If it's too loud or too soft, let me know, because I can easily turn it down or up. I definitely don't want it to be too loud, so it's all you're getting is blasted, you know, with this great music. But I also don't want it so soft that it's like, is it playing or not? So yeah, Zoom is a nice option, and maybe I'll look at that at some point in the future. But for right now, what the plan is actually to probably just use Skype and do it that way. But I have to get into that a little bit more. I've got to experiment. Got to find some volunteers to come on and do that as well. So, hope everybody's doing well. Things are good here. I've got the mug. Hear that? I've got the big mug, and it's about halfway full. You can sort of see in there. Oh, this way. Here it is. Oh, I don't want to go too far. I'll pour it all over my computer here. Of hydrogen hydroxide. It is definitely hydrogen hydroxide day. It's a nice relaxing molecule. Most amazing. So cheers to that. Yeah, Patrick, this is my day job. What it affords me is just higher bandwidth, so I can actually use OBS here, which I've wanted to use for a really long time. OBS allows me to share my screen, which is one of the most important things for this live stream, is to be able to do that. And you know, I thought for a little while, it's like, well, you know, I can just sort of walk you through things and tell you where to point and where to look and all that. And man, that's a lot of work. And so this is a lot easier. You know, the downside is that it's not going to be daily. It's going to be, you know, whenever I'm here, which is usually the weekdays, and not even all weekdays, because they're just there sometimes isn't anything to do here, so I just stay home. So yeah, this is the day job here. It's electronics lab, and yeah, well, that is exactly true, Andy. Like I said, I have. I mean, I look around, and I have so many great things that others don't have. One of them is health. Great health. You know, no major things. You know, small things, but no. You know, feel pretty good. Sleep really well. Sometimes sleep too well. You know, no stresses, no strains, no, and you know, I'm exactly, in terms of a location, I'm exactly where I want to be. It's the place that I've dreamed of for a long time. So you know, my wealth is sky high. It's just absolutely amazing. And you know, if that means that, you know, the number of dollars isn't A large amount, I don't care about that. I don't care. As long as the bills are paid, and things are gotten when they're needed, that's about it. Sometimes it's a struggle, to get those things that are needed right away, but whatever. Everything's good. Everything's good, and like I said, I've got such extreme wealth in every other way. The people that I work with here is absolutely great. Home is the same way. I've got a great group there. So yeah, all is well. So this is Astronomy Discourse Live. We sit back, relax for a little while. I like to sort of, say it's like a virtual porch, and we just sit back. We grab our consumables of choice, whatever that may be. There are drinks, there are inhalation things, there's ingestion things, just whatever. Sit back, relax. I'm just here to sort of share a passion because I love astronomy, I love space and science and all of that, and I always have, probably always will. So that makes this kind of thing just extremely easy. So cheers. All right. Oh, cool. I'm going to put this, these kinds of things, although it's large, can so easily be just bumped and banged. And if it's anywhere within arm's reach, I'm going to do it. So I put these things way over here, way over there, so it's out of arm's reach, and that way it cannot be knocked at all. And I can grab a pen, to fumble with and all of that. So, all right, well, cool. As I said, everything is good here. Wow, we had a humdinger of a not exactly a monsoon storm, but man, last night we got probably I think a couple of inches in about half an hour. It just unloaded. It just bam, like that, and strong winds and everything else, the lightning, all that. We had flicker outages 4, 5, or 6 times or so, which is really frustrating, right? Frustrating because the power goes out, right? Out and then on, like this, turns everything off, right? So you restart the computer, right, and it comes back up, and you're ready to go again, and then it flicks off again. It's like, So, I even, after the 3rd time, I'm like, okay, I'm gonna wait for 15 or 20 minutes, and then I'm gonna turn the computer back on. And so I did, right? I sat there, went outside, and watched the storm. So oh, okay, well, it's starting to die down a little bit, so, okay. And I swear, the second I turned the computer on, blink, it blinked again. It's like, what is going on? Is there some kind of, is there some kind of conspiracy up there, just for me alone? Gotta be. So, all right, well, hope everybody's doing well. As I said, things are good here. Just sort of a normal day. What I thought I would do, and again, let me know if the music in the background is too loud, too soft, or anything, because I can easily adjust that. So just let me know. I'm gonna grab another big gulp of this. Cheers. All right, not as good as the home brew, but pretty good anyway. So, all right, well, what I thought I would do today is sort of a regular thing here that I like to do from time to time. There's so much in astronomy to do. The problem that I always have is out of the hundreds and thousands of things that we can possibly talk about every single day, it's like, what are the one or two things that can be done? And one of the things that I like to do from time to time is what's called the object of the day. And so what I do is we randomly choose either like a Messier object or an NGC object, and then we go and we just sort of investigate that object. And sometimes they're really interesting, and sometimes they're really boring, or neglected, as I call them. But yeah, let's do an NGC object of the day. Now I have a Nightbot command that will randomly choose an NGC number. So the new general catalog, the NGC catalog, has 7,840 objects in it, and they're sort of ordered by right ascension. So the low numbers start at 0 hours, and then the high numbers go to 7840, which is around 24 hours or so. Now, of course, 24 hours right ascension is sort of a wraparound. It goes back to 0 hours. So it goes from 0 hours to 23:59, and then it wraps around again. So just by knowing the NGC number, you sort of get an idea, at least in terms of where it is east and west. Now, it doesn't say anything about north and south, the declination, but you sort of can get a relatively good idea. So Nightbot, there's a Nightbot command. I think it's called NGC. So I'm going to do a bang NGC, and I think it should pick one out for us here. So keep an eye on the chat. That's what I'm going to do right now. Bam, like that. And let's see what Nightbot. It somehow does a random number generator. I'm not quite sure which one. Okay, so Nightbot for us has picked out NGC 5576. So 5576, and I know that you're not going to be able to see this, but I'm pulling up my Windows calculator here. I do not have a handy-dandy calculator here. I've got to do something about that. Anyway, 5576 divided by 7840 times 24 will give us an approximate place in the sky. So I'm seeing a right ascension of maybe around like 17 hours or so. So let's go over. I'm going to share my screen, and let me make sure that I've got it set up here. So there's so what you see is what I'm seeing. Okay, so here we go. I'm going to change the scene here, boom, like that. And so I always like to go over to Simbad first. Simbad is a great astronomical database. It's got info on practically every astronomical object, and they update these things, and I'm pretty sure they try to keep these as updated as they possibly can. And so what I'm going to do, you can sort of see the address here. I'm going to go into basic search, and I'm going to type in NGC 5576. NGC 5576. Now, most of the NGC objects are galaxies, but they can be other things too. They can be nebulae, either the gaseous type, planetary nebulae. They can be open clusters. They can be globular clusters. Sometimes they are misidentified stars. So when they were making the catalog the information that they had at the time. They looked at the image and it's like, oh, okay, well, that looks like maybe a galaxy. And it turns out that it's not. It's a star or something else. But probably this is going to be a galaxy. At 17 hours UTC, though, we might have a bit of a chance that it might be a cluster, because that right ascension sort of goes through the Milky Way, so if you're looking into the Milky Way as opposed to outside of the Milky Way, there's less of a chance it's going to be a galaxy, but I still say there's probably a good chance. Let's find out. So I'm going to do a Sinbad search. Bam. Ah, yes, it's a galaxy. Okay. So let's see what we've got here. So I'm going to zoom in a little bit so you can see a little bit better. It looks like this galaxy might be part of a cluster or just a pair, right, as they say here. So yeah, look, the RA is not quite 17 hours. It's a little bit west of that. So 14 hours, 21 minutes, 3.691 seconds, and then a declination of 3 degrees, 16 minutes, 15.78 seconds. It's an elliptical galaxy. That's what this E stands for. Pretty large, 1.8 by 1.2 arc minutes. So that's pretty big. That sort of implies that this galaxy is either intrinsically large and or it's sort of close. So here are all the magnitudes. So this UBV, JHK, blah blah blah. Those are sort of spectral bands. Sometimes you can call them colors, but they're looking at this object at a particular wavelength of light. So U is sort of towards the ultraviolet. I think it's around 4,000 angstroms or so. B is around, I think, like 4,800 angstroms. V is around 5,500 angstroms. J, H, and K are going into the infrared. So I think J is around 10,000 angstroms, about 1 micron. U, this small u is a Sloan U as opposed to a Johnson U. So it's just a slightly different wavelength and bandpass. G is approximately equal to V. R is, well, I don't think that there's an equivalent here, at least. There is a Johnson R. And then I and Z are towards the infrared. And as you can see, it is definitely brighter as you move towards the infrared. The thing about the magnitude scale, the astronomical magnitude scale, as with a lot of things dealing with astronomy, it's slightly counterintuitive. So the smaller the number, the brighter the object. So a 10.96 magnitude object here is actually fainter than 7.8. So yeah, brighter in the infrared than it is in the visible. However, this is pretty bright. So with a 10-inch telescope, you're going to be able to see this. It's not going to be very much. It's going to be a little smudgy, fuzzy, almost nothing thing. But you'll definitely be able to see it if you look, if you've got a dark sight and all of that. So Sinbad is really cool because it also shows images. So we can actually go over here and take a look at these images. Now this is taken, when you look over here on the left, it says SDSS-9. That's the Sloan Digital Sky Survey release number 9. And it's probably the latest and greatest in terms of that survey. And so as you can see, I'm sort of zooming out here a little bit. Yeah, there is a definite beautiful looking, very large, wow, very large elliptical galaxy. So these elliptical galaxies, as sort of the name implies, have an elliptical shape, right? They're usually oval shaped, elliptical shaped. One of the interesting characteristics of these kinds of galaxies is that they're as opposed to like a spiral galaxy, you don't really see any spiral arms, you don't see any gas and dust, you just see a fuzz. And amazingly enough, that fuzz, all of that fuzz is stars. All of that is stars. Now we can zoom in a little bit here, and I'm going into speculation land a little bit, but you see these really faint fuzzy things here? Those probably, possibly, I guess, are globular clusters that are associated with this galaxy, not with ours. Pretty much everything else that you see in here, all these stars, especially ones that have diffraction spikes and stuff, these are foreground stars that are in our galaxy. So these galaxies are way out there, and then between these galaxies and us are all these other stars. Now, according to Sinbad, this group of galaxies is actually a pair. So, I mean, it's hard to know exactly. You have to make some kind of different measurements to really know that for sure. But at least they're nearby. Now, if these two galaxies are actually about the same distance from us, then obviously this galaxy is a little bit smaller than this one. In fact, quite a bit smaller. But if these two galaxies are actually intrinsically the same size, then this guy, well, that means, of course, that this guy is actually further away, right? Because the farther away something is, the smaller it actually looks. So, and also the fainter it's going to be, too. So yeah, there's a lot of things going on. Oh, excuse me. I'm going to start yawning again. Isn't that horrible? Anyway, so what I like to do here is I just like to scan around and see if there's anything else interesting around. It looks like there's another spiral galaxy of some sort here, kind of almost edge on, but pretty nice looking. Most spiral galaxies are pretty round when you look at them face on, as if you're way above them and looking down on them. But because they're flat and can be angled in a certain way, you get these shapes where you've got a long axis and a short axis here. This is called the major axis. This is called the minor axis. And you can see that there's a central core, and you can see what look like some spiral arms here and some gas and dust and who knows what else. It looks like there might be a galaxy way behind. Again, a lot of these things here are foreground stars. But anyway, oh, and here's another little fuzzy spiral here to see how it's more face on, and it's definitely a spiral, although probably much further away than all these other ones because it's so much smaller, right? Anyway, so here's our object of the day, 5576. NGC 5576, this big, huge elliptical galaxy here. So very cool. Let's just scan around a little bit more. Oh, here's some kind of a flaw in the image. Maybe it's a cosmic ray or a satellite moved through. Who knows, right? Who knows? All kinds of things. They stitch these things together pretty well. Bright stars tend to, do all kinds of weird optical things. You got some rainbow effects here, and whatnot. It's saturating the camera, so it does all kinds of crazy weird things. Oh, here's some more galaxies up here. So yeah, these are kind of interesting, aren't they? There's a almost looks like there's a bar here with a ring and then some arms coming off. This looks like a spiral too, but it's almost edge on. But wow, it's curled up and down like that. We're seeing that almost edge on, and then this one looks almost face on. Almost looks like maybe it's behind these two. It's with just this information, we don't have a clue. But maybe this one and this one are about the same distance. Oh, it's so hard to tell. So hard to tell. So all right. Anyway, well, since we went up, let's go down a little bit, see if there's anything else around. There's always galaxies around. Always galaxies. There are there's so many. There's just, there are lifetimes and lifetimes and lifetimes of work here. One could spend an entire lifetime just looking at one galaxy and figuring out all the characteristics of it. We're just going to spend a little bit of time on one of them here. So NGC 5576. So let's go back to Sinbad, and it contains usually some other information too. It's got a bunch of different names, and usually these are just different surveys or catalogs, right? So a survey is looking for certain characteristics, elliptical galaxies that are a certain size or a certain distance or a certain color, or all kinds of things. And so every object usually has many different names, and this is no exception. So NGC 5576, of course, it has a UGC number. It has a Sloan Digital Sky Survey number, which, as you can see, is just the right ascension and the declination. So I find that incredibly useful, that the names of these objects are just the location of them in the sky. I think that tells us a lot. There's a lot of astronomers who sort of make fun of these names or think that they're dumb or bad or anything. I think they're incredibly useful because they tell me where is it in the sky, and that is a pretty important piece of information. So all right, well, cool. Let's keep going down here. Wow, lots of references. This object has been studied quite a bit. 291 scientific papers that at least according to Sinbad, claim to discuss this object in some way. So we'll look at that relatively soon. It looks like there's some distance and velocity measurements here, so let's take a look at that. We can see how far away this guy is and how it's moving. So it looks like, I'm going to pull up my calculator again, and again, my apologies for not having a calculator on hand, an actual calculator. But anyway, this is saying, or showing at least, that this galaxy has been measured to be, that's pretty consistent too, maybe around like 24 or 25 megaparsecs, so that's 25 million parsecs. So a parsec is 3.26 light years. 3.26 million light years is a megaparsec, so I can do that times 10 to the 6th, and then we multiply that by, let's just take the average here, so it's about 24, something like that. Hello.
Yeah, don't say I never gave you anything.
All right, sorry about that. Just, you know, that's one of the hazards of being here at work, is that coworkers come in and hand me pieces of paper. So just going to have to deal with that. So, okay. So I'm going to multiply 3.26 megaparsecs by 24, and we get about 78 million light years away. So yeah, you know, that's not really close. You know, the closest large galaxy to us is the Andromeda galaxy, and it's about 2.2 million light years away. You know, so 78 million light years away isn't, it definitely isn't sort of neighborhood, but it's you know, relatively close. It's not a billion light years away. So yeah, that, you know, 78 million, that sort of makes sense. That's why it looks so big and so bright and everything else. We can see a lot of details in there because it is relatively close, and ellipticals do tend to be relatively large. So, oh, I'm just okay, yeah, that'll work. Okay, so come back down over here. We can look at the radial velocity. So that's how fast it's either moving away from us or towards us. And in this case, a positive value there means that that it's moving away from us. And again, you know, there's pretty good consistency here. I'm seeing what, maybe about 1,500 kilometers per second. So I mean, it's trucking, right? But that again is a relative velocity, and it's also just radially, right? So it's not saying anything about how it's moving north or south, east and west, just how it's moving this way. So, you know, even if, you know, this galaxy is moving away from us sort of at an angle, it's still going to have some kind of radial component, X, Y, and Z, right? The radial component in this case would be the Z-axis. So pretty good agreement there. You know, one of the things that I really like about SIMBAD is that, you know, it shows where it gets that information from. You can actually go to the scientific paper and see exactly how they arrived at those numbers. And I think that's great. You know, me being a scientist, I need to be shown that. So, all right, some observing logs. I'm not going to worry about that too much down here. I guess, you know, what we should do, we should go and look and see if the Hubble Space Telescope has ever looked at this object. The fact that there are so many references probably has. So I'm going to switch back to my main view really quick while I pull up the HST archive, because I don't know if I've got that in here or not. HST archive search. Let's see if it comes up here. Yeah, that's what I'm looking for. Okay, so I'll switch it back now. I'm going to check the chat too really quick. Yeah, no, not the boss. That was just a co-worker, but yeah, I've got to get a calculator here. I've got to get. Drives me insane that I have to use these dumb things on the screen, right? All right, so I'm going to switch back to the browser view, and you can see here's the HST data search, and we're going to just type in NGC, what was it, 5576, 5576, NGC 5576, and we'll just look for everything here, all images, all spectra, everything else. And yeah, you know, I think with that many references, I think there's a good chance that we're gonna get some hits here. Let's see. Oh yeah, okay. Not too many, only 20. So I'll sort this by date, so we can sort of see when it was last observed. So yeah, you know, hasn't been recently observed. It was observed in 2005, 02, 01, and 1999. So so let's see here. The ones in 2005, you can sort of look at the proposal ID over here to group the observations. So you can sort of see that this is sort of one set, and it looks like they looked at this field at least at 3 different wavelengths: 2716 angstroms, 3362, and 5355. So these first two are very much in the ultraviolet, which of course you can do in space. Can't do that really well down here on the ground. The atmosphere absorbs all of that. And then there's one visible wavelength object. So very ultraviolet, sort of ultraviolet, and 5355 is sort of green. So let's take a look and see what they're doing here. You can see the exposure times: 2500 seconds, 1880 angstroms, 424 seconds. So long, medium, and short exposures here, just one exposure each. You also have to remember that the HST is orbiting the Earth, so they don't have a lot of time. They can't do long exposures. The most they can really do is well, it's a 90-minute orbit, so half of that, the Earth is in the way. So the ultimate longest is 45 minutes, and you're not going to get that long either. You're probably going to get 35 minutes. So 2,500 seconds is what? 41 minutes. So yeah, that's about as long as you can go on a single exposure, because you're just going to start running into the Earth at that point. So yeah, let's take a look at these. This was using the ACS instrument, which I never remember what that stands for, but I think it's an imaging thing. So let's find out. You can see, yeah. So there we go. That is definitely an elliptical galaxy, for sure. Don't see any spirals or of any sort, anything like that. But yeah, so that's the kind of data. Now, this is a JPEG image, so it's not sort of scientifically valid data. But for us, just looking here, it's definitely good enough. So there's that one. That was the very ultraviolet one. Let's look at the sort of less ultraviolet one. Ooh, okay. Well, it was a shorter exposure, but look how much brighter it is. And then I would say that probably even the visible one might even look even brighter than that. So yeah. So definitely brighter towards the visible and the infrared, just as Simbad implied. They shorten the exposure times down, and you see a lot more. So very cool. Elliptical galaxies, to sort of look at them, aren't necessarily the most interesting thing in the world, and it's kind of hard to tell if we're looking at foreground stars here. There's this one sort of extended, if you can zoom in on that or not. There's a little, I don't know if you can see it or not, but there's a little extended object here of some sort. So with the HST, we're not going to have any kind of atmospheric distortion or anything. You still have to deal with the optics, but you're going to get as sharp as images as you possibly can. So seeing any extended objects like this is probably the real deal. I think, are we seeing that? Yeah, see, we're seeing that here too. So yeah, kind of hard to tell. We can go back to the Sloan Digital Sky Survey image and see. So the orientation here is different, slightly different. I'm wondering if we're seeing, not quite sure what we're seeing there, because I'm looking at the Sloan Sky Survey here and not really seeing any extended objects. The orientation here looks different as well, and the field of view is different too. So it's kind of hard to tell. I'm sort of looking maybe for these two stars on either side, equidistant. Are we seeing that here? Ooh, I don't know. I'm not seeing anything like that. So yeah, it's hard to tell exactly what is going on there. Let's see what this group, they took a bunch of images, more in the visible and towards the red. You see, these are the angstroms here. It looks like, yeah, STIS is a spectrometer, so these are probably spectra, which of course are extremely interesting anyway. Each one of these emissions here has meaning, but a lot of times these things are extremely complicated, and this is not an exception to that at all. But the shape of this, see how it goes up and then down and then up and down and all that. Yeah, I mean, there's a lot of action here. Probably a little bit of noise too, but yeah, and we're seeing a lot of spectral information here too. Pretty narrow band, right? This is only 500 angstroms, from 8300 to 8800 angstroms, so pretty narrow band. But yeah, let's stick with the images. So with PIC 2, the Wide Field Planetary Camera 2, back in 2001. Let's see what that shows. yeah, so again, you know, it is an elliptical galaxy, so there's not going to be a lot of details here, and without sort of diving into what they're up to, it's hard to know exactly what they're looking at. We can definitely find out a little bit more information by going over to the proposal ID 9107 and looking and seeing, maybe getting an idea. Okay, so searches for supermassive black holes in galaxy center conducted with HST and other telescopes have led to the discoveries that, one, most or all hot galaxies contain massive dark objects at their centers, presumably black holes, and two, there is a remarkably tight correlation between the black hole mass and the luminosity-weighted velocity dispersion of the hot component of the galaxy. So, okay, yeah, so it looks like they are studying this object to get an idea about the so-called, you know, black hole within the centers. So, okay, yeah, you know, this doesn't give a lot of info, but you know, the fact that we have spectral information and image information here sort of tracks with, you know, the fact that they're trying, you know, to correlate bright things with velocities. So yeah, okay, that's kind of cool. Pretty cool. We can dive into this a little bit more. Look at a few others of these. So this is centered around 5439 angstroms. Let's look at a really red one, 8,000 angstroms. Yeah, so not going to look much different, but yeah, there you go. There's the elliptical galaxy we're looking at today, at least. Very bright center. That you know, that almost looks overexposed. We would have to, you know, actually grab the raw data, you know, the raw calibrated data to really get a sense of whether this central region is actually overexposed, or if just, you know, our quick look at it here with a JPEG image, they've just, you know, chopped off the top and you know, we're not able to see much. But you can see all the fuzz around it. All that fuzz is individual stars. That just is mind-blowing, isn't it? Just absolutely incredible. Hey there, I'm Niji. Nice to have you in the chat. Hope everything's going well. Niji is one of my Patreon supporters, so feel free to check that out if you so desire. Let's see what else we've got here. So yeah, they were just looking at it, a bunch of different exposures, same wavelength, same exposure time. They're just collecting lots of data, right? Well, they did this a few times. Awesome. Oh, sorry about that. You know, this is a casual get-together, so, you know, yawning and all that is definitely allowed. Speaking of which, I'm going to grab another gulp here. All right, well, great. You know, usually these objects of the day go a little bit longer, so I think that's what I'm going to do here too. We've got one more. They observed this back in 1999 with PIC 2 as well. Just 1,000 seconds worth of exposure. Let's take a look at those. It's probably going to look about the same. Yep, it does. It does. Don't quite know what these folks were up to. So snapshots of large, complete sample of early type galaxies. Early type wood matching elliptical, with the object of examining nuclear morphology. The survey will complement this person's snapshot study of later Hubble types and provide a database for the investigation of correlations of properties such as dust, metallicity, and colors. Cool. So yeah, these folks were actually looking at the central region of this galaxy. So my guess is that this isn't actually overexposed. It's just so happens to be in this image how it's been processed. But we can actually, and this is one of the other really cool things, at least with this database, is we can actually dive into the papers and see how and when this data is used. And as you can see in this case, holy moly, it's been used and used and reused, even up to relatively recently, 2018, in the monthly notices of the Royal Astronomical Society. This data was used in some way. Now, are there authors here? Yeah, so Walter Jaffe, and I'm not going to try that name. So let's see if Jaffe is an author anywhere. I'm not seeing his name coming up here at all. So usually the observers, write papers about their observations, but I'm not seeing anything there. Leiden? Is there a Leiden or a Leiden here? Wonder what happened. They collected this data back in 1999, March 20th, 1999, and they don't seem to have done anything with it. But others did, right? Once the data became publicly available, after a year or two, others, it looks like, grabbed it and did something with it. Let's just look at one of the papers here and see if we can see what they're talking about in terms of WIPIC 2 images of the central regions of early type galaxies. The data, I like it. So this is a 2001 astrophysical or astronomical journal article. It's probably take us to the ADS. Yep. And then we can go to archive. Yay. Oh, there he is. There he is. So yeah, he just wasn't first or second author. He was third author in this case. So okay, he is there. Good. Like to see that. Let's see if we can actually find these observations. They probably have, or they might have, at least, some pictures. I always like to look at pictures if we can. Data reduction, data analysis. It's a long paper. Probably all the figures and images and tables and everything are at the end, it looks like. So I need to go through this a little bit. Sorry if you're getting dizzy watching all of these. Flyby conclusions. Here's some appendices. Here's the references. Yay. Okay, so here's some plots, luminosity profiles. I was hoping that they would have a some images for us, but maybe not. Depends on what they're going for, what they're looking at. Yeah, I'm not seeing much here. Color diagrams. NGC 5576. Let's see if it's on the list here. Yep, there it is. Right there, for what it's worth. So this definitely was part of this paper, but yeah, you know, without diving into this a little bit more, we're not gonna find out much, and I'm not gonna do it now. I think what we should probably do, we're coming up to the top of the hour. Let's hold off on this and continue looking at this object tomorrow. Usually that's how it goes. That's one of the really cool things about this kind of casual live stream is that you know, if we're not able to look at it today, we can look at it next time. And I do have to say next time and not tomorrow, because today is Friday. I'm probably not going to be here tomorrow or the next day. I might be here Monday. I might not. Just keep an eye out. That's, you know, pretty much all I can promise. Yeah, definitely be back here sometime early next week, for sure, at 22 hours UTC, and we'll keep taking a look at this interesting elliptical galaxy for a while. It's very well studied. So I'd like to sort of understand a little bit more about why it is so much studied. It's really bright. It's really big and close and everything. So you know, that makes it easy to study. You know, what makes this so interesting that it's got like 291 references. So we need to find out a little bit more about that. But for now, I think I'm going to get out of here. I'm going to take one more big gulp of this, because I'm going to get out of here too. So cheers. All right. Excellent. All right, I'm going to get out of here. Peace, cheers, and all that. Make sure to hit the thumbs up if you so desire. Share this around. I want to continue sharing my passion, and the more I can share, the happier I will be. So, and I just like talking about astronomy anyway, to as many people as possible. So, okay, everybody, I'm going to get out of here for now. Peace, cheers, and all that. I will see you. I've got to get my YouTube thing ready to stop the stream. Okay, I'm going to get out of here. I will see you next time. It'll be September. It'll be September the next time we're together. So we're definitely going to have to come back to this object, but I also want to talk about the September events, celestial events. That'll be up to. As I say, there's always so much to talk about. It's just too much. It's too much. What do you do? I don't know. It's a good problem to have. So, okay, everybody, I'm going to get out of here. Have a great one. I will see you next time. 22 hours UTC for sure. It'll be Monday or Tuesday, though. So just keep an eye out. You can keep an eye out either on the YouTube channel here or over on my Discord server. There's links to that down below. Okay, everybody, I'm really going to go this time. I'll see you later. Bye.